Welcome to Lacea class. I am your teacher, John Lacea.
A blessed day to everyone! Today, we are going to learn about game design and development using my developed two-player game entitled Lacea's Shoot Up. I taught the subject ITE 158, Game Design and Development. My students always ask me if I made a game. I responded them positively with humbleness. I shared the source code of the game that I made so that they will be inspired and challenged to develop their own game as a project requirement. The Lacea's Shoot Up game was written in C# programming language. It covers GDI plus graphics, double buffering technique of animation, collision detection between two circles, and game message loop. The main objective of the game is to shoot the opponent's ball by guessing the angle of trajectory and velocity of the ball and obtain a higher score than the other player. For example, race to 100 points. Whoever garner a 100 point first will win the shoot up game. My game design is simple. I position the two players' ball, one on the left edge for player number 1 and on the right edge for player number 2. The two players' control panels are located at the bottom. The player 1 will be the first to shoot the opponent's ball by entering the angle of trajectory and velocity and then click the shoot up button. The next player will shoot up alternately. If there is a hit, then the player will receive 10 points score. It will be displayed at the top of the screen. The vertical location of the two players' ball will be randomly placed every time there is a hit so that both players will face difficulty to guess the angle of trajectory and the ball's velocity. The projectile is any object thrown into the air. Projectile motion is motion in a vertical plane. Anyone who has tossed any kind of object into the air has observed projectile motion. If the effects of air resistance and the rotation of Earth are neglected, the path of a projectile in Earth's gravity field is curved in the shape of a parabola. The positive x direction is horizontal and to the right, and the y direction is vertical and positive upward. For example, a projectile lands from the origin with an initial speed or velocity of 50 meters per second at various angles of projection shown below. For example, if the angle is 75%, therefore the trajectory with a velocity or speed of 50 meters per second will look like this. If the angle chosen is 45 degrees with a velocity or speed of 50 meters, the angle of trajectory of the object thrown will look like this, and it will have a longer distance to travel. These are the two formulas to compute the trajectory path of an object thrown from an initial location from the left. Delta x is equal to x plus the product of the initial velocity at the x-axis and the t time to be added to the product of wind speed and the time raised to a power of 2. Delta y is equal to y to be added to the product of the initial velocity at y-axis to the negative of that time to be added to the product of gravity and time raised to a power of 2, where x stands for starting x location of the ball, y stands for starting y location of the ball, delta x stands for change of x, delta y stands for change of y, velocity x stands for initial velocity at x-axis, velocity y stands for initial velocity at y-axis, wind speed stands for the wind air resistance, gravity stands for the earth gravity constant in 9.8 meters per second, and t stands for time, which is a parametric equation. The time is a parametric equation, so that the object will move. We need to increment the time. For example, the time will begin at time 0. If we increment it with 0.01, so 0 plus 0.01, the time now will become 0.01. And then if we increment it with 0.01 to be added to 0.01, it will become 0.02. And then if we increment it with 0.01, 0.02 plus 0.01 will become 0.03, and so on and so forth. We pass those changing value of time to both of these two formula in this variable t. What will happen is that this ball will move from left to right, and it follows a certain trajectory path. These are the two formulas to compute the trajectory path of an object thrown from an initial location from the right. It has similarity with the previous formulas, but the only difference is that instead of a plus here, it is changed into subtract, so that the object movement will be from right to the left, right going to the left direction. Double buffering is a technique for drawing graphics that shows less stutter, tearing, flickering, and other artifacts. Double buffering provides smooth animation. In a double buffering system, we have enough memory to store two different screen images. And so, we designate one of them as the front buffer and the other the back buffer. The front buffer is what's currently being displayed on the monitor screen. And the back buffer is where we are currently drawing, which is the memory of the computer. To take advantage of the double buffering technique of animation, in our C# code, we simply set the property double buffered to true inside the form1 class. A sprite is a two-dimensional bitmap or animated bitmap that is a character or non-player controlled character of the game. A sprite can have transparent pixels, and these transparent pixels are not displayed so that it will blend nicely on the background. For example, this sprite has transparent pixels. If we place this sprite to this background, then it is nice to see. It blends because the sprite has no background. These pictures illustrate how double buffering works. First, we draw the background image into the back buffer. Next, we draw the sprite into the back buffer. Finally, we display the contents of the back buffer to the front buffer or the memory screen quickly. In C Sharp, once we set the property double buffered to true, then it automatically applies double buffering without writing any codes. A game loop runs continuously during the gameplay. Each turn of the loop, it processes user input without blocking, updates the game state, and renders the game. It tracks the passage of time to control the rate of gameplay. The C Sharp Windows game loop is the same setup to the Win32 Windows game loop. Let us focus our attention to the definition of the method app is idle. The pick message command retrieves messages for any window that belongs to the current thread. The pick message just looks into the message queue and checks to see if any messages are waiting. If not, the program will continue on. The method pick message returns true if there is a message and false if there is no message. So if there is a message, it runs the contents of the while loop and it just continues on to the game code if there is none. Let us focus our attention to the definition of the method on application idle. The application.idle event occurs when the application finishes processing and it is about to enter the idle state. The method on application idle is the application.idle event handler. The method on application idle is always run when our game is in idle state. Inside the method on application idle lies the game message loop or game loop. This game loop will delay to maintain 30 frames per second at any hardware. Without this delay, if we run in a high-speed CPU such as Intel iCore 9, then all objects move very quickly, very fast, and it will affect the gameplay. Inside the game message loop or game loop, we may write our codes to get the user input, perform collision detection, and update the location of the objects. The command this.invalidate will redraw or refresh the form's client rectangle and calls automatically the form paint method where we draw the background image and the sprites. The Microsoft.NET Framework has plenty of application program interface or API, and one of them is the GDI Plus API that offers plenty of graphics commands to draw objects. For example, we can draw fill rectangle, ellipse, line, arc, rectangle, or this fill ellipse that I use in this game so that it will draw a ball to be controlled by the two players. A pie, fill pie, polygon, draw image, draw icon, and we can also draw a text. On the form's client rectangle. The client rectangle is the area of the window where you put graphical user interface controls and draw or paint graphics objects. The client rectangle does not include the Windows title bar. This is the area of the Windows client rectangle, or we can also call this the canvas. For example, if we set the width of 800 pixels and the height to 600 pixels of the Windows client rectangle, the Windows client rectangle is this drawn black outline rectangle to show the area. The two-dimensional coordinates of the Windows client rectangle, the origin located at x-axis 0, y-axis 0, is located at the left top corner, not at the center. The location center of the Windows client rectangle is located at x-axis 399, y-axis 299. And uh, we can determine this by dividing the width 800 by 2 and then subtracting it by 1 to get 399. Likewise, we divide that 600 by 2 and then subtracted to 1 to get the 299 y-axis. The paint event method handler, which is this form 1 underscore paint, is where you place the drawing commands to draw graphics objects inside the Windows client rectangle. For example, these are the commands written in C# to draw the various graphics primitive commands to the Windows client rectangle, such as fill rectangle, draw ellipse, draw line, draw arc, draw rectangle, fill ellipse, draw pie, fill pie, draw polygon, draw image, draw icon, and then draw string or text. To determine if we hit the ball or not, we need a collision detection between the two circles. The method circle collision will accept two circles. It will then determine the center location of the two circles, and it will be stored to variable x1, y1 for the first circle, x2, y2 for the second circle. Next, it will calculate the sum of the two radius or radii of the two circles. Next, it will perform a condition evaluation by comparing the computed Euclidean distance, which is mat.square root of this sum of the square of dx and the square of dy between the two centers of the two circles. The distance between the two centers of the two circles. And then it compares if it is less than or equal to the sum of the two radius or radii of the two circles. Then the two circles collide if it is less than or equal to. Otherwise, the two circles did not collide. The following codes show that if there is a collision between the two balls or there is a hit, then not only it rewards the player with 10 points score, but also it will change the location of the two balls randomly. The command b.next 200, 400 will return a random value from the range 200 to 400 to the variable player x of both the player 1 and then the player 2. Ladies and gentlemen, let us compile, run, and test. Player 1 will turn or shoot up first. So let us guess the angle and velocity. This is the ball of the player 1. Our objective is to shoot this player 2 ball. So I guess, an angle of 50 degrees. I will guess the velocity 150, and then after that I click shoot up. My guess was not right. So the next to shoot up is player number 2. So let us also specify the angle and velocity. For example, the angle is also 50 degrees. Velocity is, for example, 160. And then let us click the shoot up. So player 2 miss. And now it is the turn for the player 1. A while ago, it exceeded the ball and it did not hit. Probably we need to change the velocity, decrease it lower, like 140, with the same angle of trajectory, and then let us click shoot up. Finally, my guess is correct, so I was rewarded 10 points. And my score now is 10 points, whereas the player number 2 is 0. Now let us play now the player number 2, and let us guess the angle and velocity. So I think 50 still the angle, and then the velocity is 160. So let us click the shoot up. Still it is not right. So the next to turn is player number 1. So let me decrease the velocity with the same angle, 50. The velocity now is 130, and let us click shoot up. And my guess is not right. Now it is the turn for the player 2 to shoot up. Let us increase the velocity to 170 with the same angle of trajectory, 50 degrees. So let us click shoot up. Now that player 2 hit the ball of player 1, the score now is even, both 10 points each. And the next to shoot up, alternately, is player number 1. So let me change the velocity to 160, the same angle, 50 degrees. I click shoot up, and my guess is not right. Now player 2 will shoot up. So let us change the angle to 45 degrees, and then decrease the velocity to 160, and then click shoot up. And then player 2 hit the player number 1 ball, and it receives a 10 points. Now the score is 20 for player 2 and 10 points for player 1. Now it is the turn for player 1 to shoot up. So we can also change the angle to 45. And then I am thinking if I will retain that 160 or not. So I decided to retain that 160. So I click shoot up. And still it is not that correct. Now the player 2 will shoot up 45 degrees angle, and then velocity, let me change the velocity to 150 and then click shoot up. It did not reach that target. Now the turn now for player 1 to shoot up 41 degrees. So let us decrease the velocity from 160 to 150 and then click shoot up. Now the score is even, and it is a tie. Let me click F1.
That ends our topic for today. I hope you are inspired in my class. Thank you for watching. God bless us.